In our last example, we got to the point where we had to factor a trinomial with some fairly large coefficients in it. This is not uncommon in applications that the values you end up with make the factoring maybe a little more difficult. In that case, one thing that you can rely back on in applications is an alternate technique for solving a quadratic equation, which hopefully you learned in a previous math class. Here at PCC, we generally teach this technique in Math 65, and that is solving with the quadratic formula. Now, the quadratic formula is set up to go ahead and solve any quadratic equation based on its coefficients. So for instance, if we have a quadratic equation, ax squared plus bx plus c. So I'm using a, b, and c to represent the coefficients, and this trinomial is equal to 0. Then the quadratic formula says that you can solve for x using the following formula, and this is a big fraction, so notice my big fraction bar. You're going to take the b, which is the middle coefficient, and negate it initially in the numerator, and then you're going to have plus or minus, because we have two solutions to a quadratic equation, plus or minus the square root of, take that b and square it, minus 4 times the coefficient a times the coefficient c. All of that, b squared minus 4ac, is underneath the square root, and then in the denominator of this entire numerator, we would have 2 times the coefficient a. So this is a formula for finding the values of x where you just plug in a, b, and c instead of factoring. So we can do that with this example we did previously. In that last example, here we've got 5x squared minus 72 minus x minus 45 equal to 0. So the a value is the coefficient of the x squared term, so that would be 5. The b is the coefficient of the x term, which is negative 72. And c is the constant term. Now that is important in the formula. A is always the coefficient of x squared, b is always the coefficient of x, and c is always the constant term. So it's very helpful if you write everything in descending order, just like you would if you were factoring. So then we can solve for x using this formula. So we'd have negative b is negative 72. Now notice that those two negatives are going to cancel each other out. Plus or minus the square root of b, which is negative 72 squared, minus 4 times a, which is 5, times c, which is negative 45. And that is all over, make sure you put it all over 2 times a, which is 5. Now we just want to go ahead and simplify. So the two negatives make a positive 72, plus or minus the square root. Negative 72 squared, any negative number is going to become a positive when you square it, and specifically, you can use your calculator to get 5,184. Now, we're going to be subtracting, but 4 times 5 times a negative is a negative number. Technically, two negatives are going to make this be a positive or a plus, what we get when we do this multiplication. So 4 times 5 times 45 gives me 900. So watch your signs. Those two negatives also make that into a addition. All over 2 times 5 is 10. Continue simplifying. 72 plus or minus the square root, adding 900 and 5,184, we get 6,084. And since we already knew this would factor, the one nice thing about something that factors is that this square root in the quadratic formula will always come out as an exact number. So it turns out this square root of 6,084, you can use your calculator, comes out to 78, and that's all over 10. Now, once you get down to this stage, the plus or minus is going to give you the two different answers in the following way. X is equal to 72 plus 78 over 10 as one of your answers. And then as the other, use the minus, 72 minus 78 over 10. So finishing up each of these individual calculations, 72 plus 78 is 150 over 10. That would be 15. And then the other one, 72 minus 78 is negative 6 over 10. And simplifying, that would be negative 3/5. And these are the exact same values we got when we factored. So the quadratic formula is an alternative way to get those numbers when you have really big values for your coefficients that make factoring really hard in a particular application problem. Okay.